Hello students, Dr. Sansom here. I want to talk about dimensional analysis. We had to go through it kind of quickly in class. Many of you are going to be familiar with it, but if it's new and you want just a refresher, I'm going to try and help you out here. So dimensional analysis is essentially a process to change the units of a number. So for example, we could have 10 grams. What if I want to know how many kilograms that is? Well, I know there's 1,000 grams in 1 kilogram. I can convert it into kilograms. I get 0.01 kilograms. Notice this thing right here. This one is called a conversion factor. And a conversion factor always has a value that's equal to 1, which means the top equals the bottom. In this case, 1 kilogram equals 1,000 grams. This is the whole key to why we're allowed to do this, because we're just multiplying by 1. Multiplying by 1 never changes the value of a thing, right? It's like the multiplicative identity. And so we're allowed to do this. And it happens to be a very useful way to approach problem solving in chemistry. So we're going to do a couple of examples here. The first example I want to do is the example that we went through very fast in class. So I want to know how many seconds are in 1.38 days. Okay. Now for this one, they didn't give me any conversion factors, but they're sort of assuming I know how many hours and minutes and seconds are going to be in a day. So I'm going to start with the number they gave me, 1.38 days. And I'm going to ask myself, well, what can I turn days into? I know that there's 24 hours in a day. So I've got to choose if 24 hours equals 1 day. I could put 24 hours on the top, or I could put it on the bottom. I want to put it on the bottom because I've got days on the top right now, this one right here. And if I put it on the bottom, then I'm going to be able to cancel those out. So I'm going to put 1 day on the bottom and 24 hours on the top. And now I've gotten myself successfully to hours, which is closer to seconds, but I still have to go to minutes and then seconds. So I'm going to do 2 more steps here. I know in 1 hour, I'm going to have 60 minutes. My hours are going to cancel out, just like my days did. And I know in 60 minutes, I'm going to have, in one minute, I'm going to have 60 seconds. So my minutes will cancel out, and now I'm left with seconds. So what I've done is successfully changed from days to seconds without altering the value of the quantity that I started with. That's what's so powerful here. Okay, when I multiply this out, I get 119,232 seconds. To make my sig figs correct, because I started with 3 sig figs, we're going to round that off to 119,000 seconds. Okay, pretty straightforward. In this case, I had to sort of produce all of the conversion factors that I used just based on my background knowledge. There's other situations where you're going to have a complicated problem and they're going to give you conversion factors in the context of the problem. So I'm going to write out an example of that. So this is an example of a word problem. So a gram of gasoline produces 45 kilojoules of energy when burned. Gasoline has a density of 0.77 grams per milliliter. How much energy is produced by burning 28 liters of gasoline? Okay, I'm going to break this down for you here in terms of the information they gave us. And what we're looking for here, they gave us 3 different numbers, which is very exciting. We like having the numbers. but there's all these words around the numbers. So what we are looking for is we're going to look at the information and we're going to try and figure out which number is just a number and which numbers are conversion factors. If they're conversion factors, we don't want to start with those. We always want to start with the number that's just a number. So I'm going to look at this first sentence. A gram of gasoline produces 45 kilojoules of energy when burned. So that is a conversion factor. They told me that 1 gram of gasoline equals 45.0 kilojoules of energy. So I could write 1 gram over 45 kilojoules or 45 kilojoules over 1 gram. Both of those are valid conversion factors that I can create with that information. Second sentence here, they told me gasoline has a density of 0.77 grams per milliliter. I warned you guys in class to avoid these like slashes. So this is also, in fact, a compound unit or something we can use as a conversion factor. I know that 0.77 grams of gasoline equals 1 milliliter of gasoline. And so I can write 0.77 grams per milliliter. Notice I'm using the horizontal line here, not the dash or slash, right? Or I could also write 1 milliliter is the same as 0.77 grams. So those are both conversion factors. Now the last thing they said is I'm going to be burning 28 liters of gasoline. That, my friends, is just a number. And we always, when we're doing these calculations, are going to start with a number. Now, they asked me how much energy. So I've got to get from liters to energy. I have a conversion factor here that goes from milliliters to grams. And I have one that goes from grams to kilojoules. So if I can get from liters to milliliters, I should be able to figure this out. So essentially what we're doing here is just building a logical step by step way to convert these things. I've got 28 liters. I know I can do something once I get to milliliters. So I'm going to turn my liters. 1 liter is the same as 1,000 milliliters into milliliters. That was a conversion factor that I just know. Okay. Next, I'm going to use this grams and milliliters because that will help me get closer to where I can use grams and kilojoules. So my next one, I want my milliliters to be on the bottom. So I've got 1 milliliter on the bottom, 0.77 grams on the top. Cross out my milliliters. I've got grams, feeling really happy and good about myself right now. And now I've got grams. I need to turn that into kilojoules. I'm going to use this conversion factor, 45 kilojoules for 1 gram. And this is going to allow me to do my calculation. So 28 times 1,000 times 0.77 times 45. And I get for my answer here 970,200 kilojoules. That's my number of kilojoules. Now the question is, how many sig figs should I have? I've got 3 numbers they gave me. This one had 2 sig figs. This one had 2 sig figs. This one had 3 sig figs. And of course I have the definition here of 1,000 milliliters in 1 liter. That one's defined, so it has an infinite number of sig figs. But based on what I've got, my answer should have 2 sig figs. So I'm going to go with 9.7 times 10 to the 5th kilojoules. That allows me to communicate my 2 sig figs that I have in my answer. So key ideas here. When we're looking at a conversion factor versus a regular number that's not a conversion factor, we always want to start our calculation with a number that's not a conversion factor. That's just going to help us down the road. Could we put these together another way? Yes. But usually when you do it another way, or at least half the time when you do it another way, you're going to end up with the inverse of the number that you want in the end. So it just causes problems. You can still do it that way, but it's harder. So start with a number that's not a conversion factor, then step by step figure out what conversion factors you have and how you can get from what you have to what you want to have. And then you put your conversion factors together, multiply by everything on the top, divide by everything on the bottom. We just had ones on the bottom. And then you get your answer. Okay, that's everything for our dimensional analysis. Hope it's helpful.